I do want to listen to this. Of course you do. Alondra. Okay, number one. Stefan. So here we go. Number one. So first of all, if I'm going to graph y equals 3 times 2 to the x, okay? Don't use your calculator. I need 3 things. And they're easy. I know it's going to have to go through 3 because anything to the 0 power is 1. And 3 times 1 is 3, so at 0 it's got to be 3. That's the first thing I'm going to be looking for is this value. The next thing I'm going to be looking for is the curve. It's got to go through 3, and it's got to be growth. It's got to curve up like this. It must, because it's growth, all right? The next thing is just get close to the x-axis, but it never touches the x-axis. So I'm looking for 3 things. The shape, okay, it's got an exponential growth shape. It goes through at 3, and it never touches the 0. Okay, now the log,
Wait, why does it go through this? Oh, it says minus.
Okay, great question. You ready? Anything at 0 power is 1. Then 3 times 1 is 3. So at 0, it's got to be 3. Great question. Now with the log, it's the same way. If I'm going to do the other one, it's just the inverse. So if it's the inverse, it's going to go through at 3. It's going to have the same characteristics. It's going to curve like this as a log. It never touches the x-axis, all right? Has to go through 3, and it starts to curve and level off like a log equation does. Okay, that should be easy. You don't need to use a calculator. You just have to have these shapes. Okay, now, what is the domain? Well, the domain of the log graph, it never touches the x-axis, so it never becomes 0. But the domain is simply going to be x is greater than 0. Okay, that should be easy. Everybody should be able to get those right. Okay, now let's take a look at number 3, and I'll probably do a lot of these on a separate sheet of paper so I have room. Okay, so if you have an extra sheet of paper out, that'd probably be great. Okay, number 3. Let me do this on a separate sheet of paper. So 3a. So log, it has a base. It's a base 10. And all we're going to do to rewrite is go 10 to the x equals 100. That's all I'm going to do. Let's go 10 to the x power equals 100. 10 to the x equals 100. I just rewrote it in exponential form. 3b, it has a base. It's a hidden base. It's really base e. It's any ln, it really means log of base e. But we just write it as ln instead. So we're going to go e to the 7 equals x. So we're going to go e to the 7 equals x. We just have to recognize that ln means log base e. Here's my base, e to the 7 equals x. Okay, that's all. Alright, then 4. We're going to solve it. A couple of different ways to solve it, but with 4, because it's a 10, I can go straight to plain old calculator log. So in 4, because it's already 10, we're going to go straight to, fold this as I go, so you can see how it's going to work. I'm just going to go log of 756. Now the base is base 10, but I don't need to write it because it's a calculator log and it's base 10, it's implied. I'm just going to use my calculator. What is log of 756? I know log of 756 is about 2.88 approximately. So we're going to say x is approximately equal to a 2.88. I'll round it to 88, okay? How's that? And again, don't worry about the rounding. If you have the right number there, then obviously the rounding won't matter, okay? 5. Okay, because it's e, I'm going to use the natural log. So I'm going to rewrite it as ln of 22 equals x. And I have an ln button on my calculator. I have a natural log. My natural log button's right there. It's just ln of 22. And answer about 3.09. So x is approximately equal to 3.09. Okay, real quick. Check for understanding. Thumbs up. Thumbs up. Everybody good on these problems? Okay. These shouldn't be bad. These should be pretty easy. Okay. Okay, let's go to 5. Now, if you're fancy pants Madeline, she has a calculator that can do other bases. The rest of us, you know, we don't. Some of you might have other bases, but what I'm going to do on 6 is if I have 5 to the x equals 245, I just want to bring down the x, right? And the way you bring down the x is just to take the log of both sides. So I'll take the log of 5 to the x equals a log of 245, because that's going to set up bringing down the exponent. So then the exponent floats down, and I'll have x times the log of 5 equals a log of 245. Log of 5 is just a number, so I'm just going to divide. So I'll divide by log of 5, divide by log of 5, right? And I'm just going to use my calculator. Make sure you close the parentheses. I'll say this all the time. You have to close the parentheses right here, otherwise you're going to have a mistake, okay? So I'm just going to go log 245, close the parentheses, divided by log of 5, close parentheses, and I get an answer about 3.42, approximately equal to a 3.42, okay? Not too bad? No. Okay, 7 is the exact same type of problem, except we just have to divide by 3 first. 7 is the exact same type of problem as number 6. The only difference is let's just divide by 3 first. So 7 is this 3 times 2 to the x equals 636. First thing I'm going to do is just divide by 3, divide by 3. Don't multiply those. Aunt Sally will be really upset.
Aunt Sally?
Aunt Sally, please excuse my dear Aunt Sally. You guys ever hear order of operations that way? It'll blow order of operations, right? You got to do the exponent before you multiply, so let's divide by 3. Divide by 3, so 636 divided by 3. Divided by 3 is 212. So I have a 2 to the x equals 212. And now I'm going to do this problem exactly like I did 6. Exactly. I need to float the exponent down. So to get the exponent down, I'm just going to take the log of both sides. I'll probably skip a step because you guys already know what I'm going to do. So I have x times the log of 2 equals the log of 212, right? So brought the x down, took the log of it. Divide by log of 2, because that's just a number in my calculator. Okay, so what's 212? Log, clear. Log 212. Close your parentheses. Divide by log of 2, and I get an answer about 7.73, approximately equal to about a 7.73. Okay, how am I doing? So far, so good?
Yeah.
Okay. All right, 8. Same kind of problem. The only difference is that the very last step will be to divide by 3, but I'll show you what I mean. So first step, let's take the log of both sides. For number 8, I've got this 5 to the 3x equals 89. But I need to bring the 3x down, right? So if I need to bring the 3x down, I'm going to just take the log of both sides. So I'll have a 3x. Log 5 equals log 89, right? Well, log 5 is just a number in my calculator, so I'm going to divide by log 5. Divide by log 5. Divide by log 5. So I'll have 3x equals, I don't know, let's see what this is equal to. Okay, clear. Let's go log 89, clear, log 89 divided by, close parentheses, log 5, close parentheses. I get an answer about 2.7889, but I'm going to keep that in my calculator because I'm going to divide by 3 next, so 2.7889, but divide by 3, right? Divide by 3, just divide by 3, and I get an answer of about 0.93. How's that? So x is approximately equal to 0.93. Okay, now all 3 of those are pretty much the same. 4, 5, 6, actually all 5, 4, 5, 6, 7, 8. We're all pretty much the same. You guys, thumbs up on those, right? Big key is if you want to bring that x down, you got to log it, right? Mm-hmm. Now 9 can be done one of two ways. One of two ways. The easy way. Do you want to see the easy way?
Yes.
Okay, I know that 8 is the same thing as 2 cubed. This is the easy way to do it. Do you agree with that? So if I have a 2 to the x plus 1 equals a 2 to the 2x, then what's up here has to be equal to this, right? Because if it's 2 to that, then just by pure reason, x plus 1's got to be equal to 2x. Right? I mean, if 2 is something, 2 is something. These two have to be equal, so then subtract x, and x is equal to 1.
Whoa.
What?
Minus x, x is equal to 1. Now, you could take the log of both sides, and you could work it out, where you do x plus 1 log of 2 is equal to 2x log of 8, of 8, and then go ahead and solve, but you're going to get the exact same answer. So if you can make them the same base, it's easier. If you can make them the same base, it's just easier to solve. Okay? You can still do it the hard way, though, if you want to. Okay? 10. 10 and 11 are easy. Honest, they're super easy. Yep. So on 10, I'm going to rewrite as log base what? Base 10 of x equals 3.5. Okay? So let's go 10 to the 3.5 equals x. So I'm going to change it from log form to exponential form. So it's going to go 10 to the 3.5 equals x. And that's going to be over 1,000. Let's check it out. Go 10 to the 3.5 power. 3,162.3. How's that? That's easy, huh? And 11, what's the base of 11? What's the base? E. So it's really could be written as log base E of x equals 6.5, but we normally wouldn't do that. We normally say, well, I don't want to write a log base E because that is just ln, but it helps us to go E to the 6.5 equals x, and what is that answer? I don't know. E to the 6.5 gives me an answer about, yeah, 665.14, blah, 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 blah. Thumbs up? Pretty easy, isn't it? Logarithms just sound hard, but they're not, are they? They're not hard at all.
Wait, why do you change the ln to log?
Great question. So when you see ln, it really means log of base E.
Okay.
No, we wouldn't write it like this normally. We just keep it as ln.
Okay.
But when I do write it this way, Lane, you can see, hey, that's my base, right? So I can go E that to that, right? Normally, I would never write it like log base E. I'd just write it ln. Because the E is implied, right? I mean, we know the E is hiding inside of there, right? Okay. All right, now 12. 12 is pretty easy, too. Honest. So on 12, I'm just going to go 4 to the 3. 4 to the 3 equals x. 4 to the third, 64. So, all the way up to 12, they're pretty easy. Now, 13 is going to take some work, but 1 through 12, you should be able to do. Everybody should be able to do 1 through 12, okay? No problems at all. Now, 13 is going to take a little bit more work. 13 might take some factoring, some solving, but let's take a look at 13, okay? So, the first thing I see on 13 is I want to bring them together as a single log. So I can solve for the log. So I'm going to rewrite as log base 2 of x times x minus 6 equals 4. Okay, now there's a little times sign I don't need to write, but you know that because it's plus here, I bring them together as times. Okay, I bring the bases together. So now I'm just going to change it from log form to exponential form. 2 to the 4, right? I'm going to go 2 to the 4 equals what's inside. So let's go from log form to exponential. 2 to the 4 equals x times x minus 6. Okay, now it's just algebra. Easy algebra, huh? So 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16. X squared minus 6x, right? I'm going to bring over the 16 because I'm going to do the F word again, that darn F word, that factoring. I know. 0 is equal to x squared minus 6x minus 16, right? I can factor. I know how to factor. X and x. What times what makes 16? 4 and 4, yeah, but that won't make a 6. But what about a 8 and 2? How about a negative 8 and a positive 2? How's that? And then when I solve these, I'll get x equals 8 and x equals negative 2. But we're going to throw away the negative 2 because you can't have a negative log. So it's just 8, right? Not bad? All right, 14. Write as a single, 14, we're going to write this as a single log, okay? So, to write as a single log, the first thing I'm going to do is bring these exponents back in. So, we had exponents that got floated out because you bring the exponent down, but this time we're going to bring the exponent back in. So, for 14, I'm going to rewrite this as log a to the 1/3 power plus log b to the 5th power minus log c. Okay, all I did, it's going to be 2 steps in this thing, but the first thing I did is brought back in the exponents. Now the second thing is I'm going to rewrite as a single log. Log of what? Log, and don't write the log again, just a single log, okay? A lot of kids mess this up because they write log more than once. It's just log of these things, A, B's, and C's, okay? Well, it's going to be an A to the 1/3 times a B to the 5th divided by C. And I would take that answer, that's fine. I would like this instead, but I would take that. Cube root of A B to the 5th over C, okay? Because 1/3 power, well, 1/3 power is really a cube root. Just looks nicer. But I'd take either one.
This doesn't change it.
No, not all. Yeah, I'll take either one. I mean, they both are correct, okay? This just looks nicer, right?
Is that just an opinion?
Yes, it's just an opinion. It depends. You know, when you go to college, you're going to find all sorts of professors with all sorts of opinions, right? What I try to do as a teacher is to get as particular as I can, because I don't know who you're going to have in college, right? So I'm going to be as picky as I can so that you're going to, oh yeah, Mr. Davies made us do that, right? And then you get the professor who doesn't care, and you go, sweet, right? Okay, 15, we're going to do just the opposite, okay? So on 15, there's a little times sign here we never write, but that little times sign is going to be a plus. There's a divide sign here, which is going to be a subtract. So I'm going to go log base 3 of x squared plus log base 3 of the 4th root of y minus log base 3 of z to the 3rd. Okay, that's the first step. Now there's 2 steps involved. Second step is to float the exponent down. Now the problem is that I really need an exponent here on the second. So I'm really, that's the same thing as a 1/4 power. You okay with that? Being a 1/4 power? 4th root, 1/4 power, right? Right? So let's float the exponents down. So the exponents are going to come down. Exponents are going to come down. Exponents are going to come down. So grand answer in expanded form is a 2 log base 3 of x plus a 1/4 log base 3 of y minus a 3 log base 3 of z. There it is. That's it. You guys can do this, can't you? Logarithms aren't hard. I know it's, you say, yeah, it's easy for you to say, Mr. Davies, but honestly, we've done harder things than this. Really have. All right. 16. Ooh, looks like a story problem. I can handle it. 10, 14. Let's get 16, okay? All right, we're almost getting there, actually. A cell biologist needs 100,000 cells for bacterial culture. She starts with a sample of 100 cells that doubles every 5 hours. So we're going to use this formula. N of T, which is the number over time, N0, which is your beginning amount, times 2 to the little t over big T. Okay, that's my doubling formula, where N of T is the number over time, N0 is beginning amount, 2 because we're doubling, that's just your double, T is your total time, and big T is your cycle of time. So let's put some things in there. So A, we need an exponential function. So we're going to go N of T equals 100 times 2 to the T over 5. That's my formula. I just plugged the 5 hours into my cycle, which is my big T. Put my 100, because that's my beginning amount, times 2. And there's my formula. Now I can use my formula, okay? So on part B, it says, all right, how many hours will it take for the population to be 100,000 cells? Well, that's my number over time. So on B, we'll set it equal to 100,000. and we'll solve for t. Now I'm eventually going to need to take a logarithm because I'm going to eventually need to bring this down. But before I do that, let's divide by 100, okay? I'm going to need to do a log, but before we do that, let's divide by 100. Get rid of that. Divide by 100. Cancel. Cancel. So use 1,000 equals 2 to the t over 5, okay? Oh, that's part of the question. Yeah, it's just part of the question. Great question. So now, well, let's bring it down, okay? How do we bring the exponent down? What are we going to do to get this down? Yeah, just log it, right? So I'll take the log of 1,000, which is going to be 3, by the way, equals t over 5 log of 2, okay? Solve for t, so let's divide by log of 2. How am I doing? Not too fast? Huh? Yeah, Alondra, that's why I asked. If I'm going too fast, please tell me, okay? And while you're catching up, I'm just going to do some division here. Clear log of 1,000, which is 3, but that's okay. Divided by log 2. So I got a 9.965 blah 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 equals t over 5. Okay, Alondra, are you caught up? Okay, now, so I just divided that. My calculus said 9.96 blah 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 blah. Multiply by 5, right? Times it by 5. So 5 times 9.965 blah 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 equals t. So take the calculator. I'll just multiply this answer times 5. And I got 49.8. And I think that's in terms of hours, isn't it? Okay. We are almost done. We are very close to done, okay? All right. 17. Seaborgium, which is probably some strange thing they make in the lab. Highly radioactive, right? With big old atom smashers probably made. Has a half-life of 4.34 minutes. That's it. So it's highly unstable, isn't it? Yeah. You know, I don't know what you guys know about science, but down in Mexico they have a big cyclotron, which is like this big, huge donut, gigantic donut. It's like 10 miles across, and they sling atoms through it, right? And then they smash atoms together, and they create all sorts of cool things.
Is that like the particle collider and
Yes, yes.
Iron Man did that, right?
So let's say they created this in a lab. So he's got 10,000 of these atoms in the lab. So let's first find a half-life function. So 17a, let's go n of t, number over time, n0, 1/2, to the same thing, t over big T, okay? Exact same formula except for its half is the rate instead of 2. So my 4.34 is a cycle of time. I'm going to put that in for t. And my 10,000 is my beginning amount. So part A is going to be n of t is equal to 10,000, 1/2 to the t over my 4.34. Okay, how am I doing? There's part A. There's my formula. Now B, I'm going to use my formula, okay? So I've got my formula set up, and B, then it says, okay, how long will it take for only one atom to be left? Because it's just going to disintegrate into nothing, okay? It's highly radioactive, all right? So we say, all right, 1 is equal to 10,000 times 1/2 to the t over 4.34. And I've got to solve. So I'm going to divide by 10,000. Divide by 10,000. Should be a 0.001. 1 divided by 10,000. Yep, it's a 0.0001 equals 1/2 to the t divided by 4.34 power, okay? So I just divide by 10,000, I got a decimal. 0.001. 4 places, right? 1, 2, 3, 4. Okay? And then I'm going to log it, right? take the log of both sides, take the log of 0.0001, which is going to be negative 4, equals t over my 4.34 log of 1/2. Okay, so log it, so I can bring it down. Got to bring that down, so I just took the log of it. Got to get rid of the log of 1/2, so I'm just going to divide by the log of 1/2. How's that, Nathan? Can you see better? Yeah. So divide by log 1/2. Divide by log of 1/2. Let's see what we get. So we go log that. Divide by log of 0.5. And I get an answer about 13.3 equals t over 4.34, right? And then finally I'll just multiply that up. I'll go 13.3 times 4.34 equals t. So times that by 4.34 and I get an answer about 57.6. Yeah, 57. I'll round up 0.7, and that's got to probably be hours, isn't it? Hours. Not bad. Pretty easy, right?
Each atom.
They just disintegrate. They just, as far as half-life.
So each atom disintegrates in like 9 minutes.
Well, it goes half and half and half, right? So you start with 10,000, and after 4.34 minutes, you're down to 5,000, and then you're down to another half of that, right? Okay, so it goes half of that, then half of that, and then half of that, and half of that. So it takes this many hours to go all the way down to 1. Okay. All right. 18. Right. Let's do 18. Almost done. Last but not least, 18. Okay. Find the magnitude of an earthquake with a seismology reading of 4.4. So, I got to go back to my notes.
Is that the magnitude?
Mm-hmm. Yeah. No, that's the intensity. That's the intensity.
Okay.
So, I've got my Richter scale is going to be m for magnitude is equal to, we had this log of I over 10 to the negative 4, okay? And then I told you, and that formula works great, but then I told you could rewrite this as log of I times the 10 to the 4th power, because we're smart enough to know that if it's a negative exponent, it can be moved, right? So I just moved it up. And you can use either one of these. It's the same thing. I just brought it up. But one thing I do know on this one, if I've got a seismology reading, that's the intensity. So on the seismograph, it's going like this, right? And it reaches 4.4 to negative 4.4, and that's my intensity. Okay, so I just put my 4.4 into here. So go m is equal to log of my 4.4 divided by 10 to the negative 4. Again, I told you could use either formula. It doesn't really matter. I'm going to use the one the book gave us. So I'm just going to go clear. Log of 4.4 divided by 10 to the negative 4 power. Uh-oh, that's going to give me a wrong answer. To the negative 4 power. And I get about 4.6 magnitude. And that's it, right?
Wow, that was really easy.
Yeah, it should be. It should be a test that we ought to have a